Hello guys, welcome to this super quick introduction to my PhD project. I am Georgia and I usually look like this. Lately I pass my time working on pharmaceutical formulations called amorphous solid dispersions. But let's take things from the start. One of the major challenges drug development faces the solubility issues of drug molecules. Why is that, you may ask? Well, orally administered drugs in the form of tablets or capsules need to be dissolved in the stomach fluids before being absorbed by the small intestine and before reaching the target. Undissolved drugs typically leave the body without inducing their pharmacological effect. This topic has long tortured scientists, but we now have a variety of techniques to bottle solubility issues. One of these is making the drug substance amorphous. But keep calm and let me explain. Solids can be found mainly in two forms. One, the stable crystalline state with a definite molecular structure in space called the crystal lattice, and two, the non-equilibrium amorphous state that is characterized by the lack of the crystal lattice. Crystalline material can be made amorphous, and amorphous can fall back to the crystalline state after time. But what happens when we try to dissolve these two forms? In order for a solution to be formed, two things are typically needed. One, for the bonds between the solute molecules to break, and two, bonds between the solvent and solute molecules to be created. So the fact that amorphous materials lack this crystal lattice structure means, one, that it is in a higher free energy state than the crystalline structure, and two, that it needs less energy for its structure to break. This means that essentially the amorphous state is more soluble than the crystalline state of the same compound, but as we discussed, it is still less stable. Here come the polymers in play, which are typically long-chain molecules and have pockets that can stabilize material in the amorphous state. They are also referred to as carriers with the amorphous materials dispersed in them, hence the name Amorphous Solid Dispersions. They can be created with a lot of techniques, one of which is spray drying. The basic principle is that polymers and drug molecules are dissolved in a common solvent. The solution is then sprayed in a chamber with a simultaneous entrance of hot air. This causes the solvent to evaporate rapidly, causing material to be frozen in the amorphous solid dispersion state in the form of really fine powder that can be turned into tablets or capsules. So ultimately, we will create different types of amorphous solid dispersions with different polymers and polymer-drug ratios and see how their solubility in the solution is affected. Based on the data, we will make an educated guess of what will happen when humans take them. Then we will have volunteers take them and see if we can actually make such a prediction. This is all towards an effort to create reliable lab tools that can predict in vivo behavior of pharmaceutical formulations.